In this video, we will be learning about multiplexer and demultiplexer. Procedure. Connections are given as per the circuit diagram. Logical inputs are given as per the circuit diagram. Observe the output and verify the truth table. Aim. To design and implement multiplexer and demultiplexer using logic gates. Theory. Multiplexer. Multiplexer means transmitting a large number of information units over a small number of channels or lines. A digital multiplexer is a combinational circuit that selects binary information from one of the many input lines and directs it to a single output line. The selection of a particular input line is controlled by a set of selection lines. Normally, there are two power in input lines and in selection lines whose bit combination determines which input is selected. Demultiplexer. The function of demultiplexer is in contrast to the multiplexer function. It takes information from one line and distributes it to a given number of output lines. For this reason, the demultiplexer is also known as a data distributor. Decoder can also be used as a demultiplexer. In this 1x4 demultiplexer circuit, the data input line goes to all of the AND gates. The data select lines enable only one gate at a time, and the data on the data input line will pass through the selected gate to the associated data output line. Circuit and truth table for multiplexer. This is the circuit for multiplexer and truth table for multiplexer. Here we can see that we have used two selector lines, four NAND gates, two NOT gates, three OR gates, and one output. As we can see here, giving 0 in both S1 and S0, we get 1 at D0, 0 at D1, D2, D3, and 1 at Y. Components for multiplexer and demultiplexer. 3 input AND gate, OR gate, NOT gate, IC trainer kit, and patch cords are used for multiplexer and demultiplexer. Simulation for multiplexer. Here we are using 2 switches, 2 NOT gates, 4 clock pulses, 4 NAND gates, 3 OR gates, and 1 bulb. We can see that by giving 0 at S1 and S0, we get D1 at D0, D1, D2, D3, and then finally we get 1 as our output in Y. By giving 1 as our input in both S1 and S0, we get D1, D2, D3, D0, D1, D2 as output 1, D3 as 0, and Y as 1. By giving 1 at S1 and 0 at S0, we get 0 at D2 and 1 at other gates. We get 1 as output in Y. Now we are moving for circuit and truth table for demultiplexer. In demultiplexer, we are using 4 AND gates, 2 NOT gates, and an input line. Simulation for demultiplexer. As we said earlier, we are using 2 switches, 1 clock pulse as an input, 4 bulbs, 4 gates, and 2 NOT gates. By giving 1 at S0 and 0 at input and S1, we get and 1 at input, we get D1 as 1 and others as 0. By giving 1 in both S1 and S0 and input as 0, we get 0 in all. By giving 1 in S1 and S0 and 1 in input, we get 1 in D3. So, this is all about demultiplexer. In the next video, we will be learning about the flip-flop and its types. Thanks for watching.